This is Euclid Book 7, proposition number 21. I'm going to go ahead and read this to you. Numbers prime to one another are the least of those which have the same ratio with them. Let A and B be numbers prime to one another. Now, the numbers 8 and 9 in themselves are not prime, but they are prime to one another because the only thing that will divide both 8 and 9 is the number 1. Okay? I say that A and B are the least of those which have the same ratio with them. For if not, there will be some numbers less than A and B which are in the same ratio with A and B. Now, we're going to, for this example, we're going to change the numbers 8 and 9 to 16 and 18. Okay? And the reason we're going to do this is because you're going to see how this works, and then you're going to see a reason why it really doesn't work. Okay? So, we have two magnitudes, A and B, and they are 16 and 18. Now, C and D are 8 and 9 respectively. Okay? And E, of course, will be 2. So I'm going to go ahead and show you this. Okay. So now, instead of A and B being 8 and 9, we're going to have A and B being 16 and 18. Okay? For if not, there will be some numbers less than A and B which are in the same ratio as A and B. Well, let them be C and D. Well, 8 is to 9 as 16 is to 18. And if you reduce the fractions 16/18, you'll find out I'm correct. Since then, the least numbers of those which have the same ratio measured those which have the same ratio the same number of times, the greater, and the less, that is, the antecedent, and the consequent, which is Euclid Book 7, proposition number 20, which is the one we did the last time. Therefore, C measures A the same number of times that D measures B. Well, 8 measures 16 twice. 9 measures 18 twice. Now, as many times as C measures A, so many units let there be in E, which is 2. Therefore, D also measures B according to the units in E. Of course so, because D measures B twice, and of course C measures A twice. And since C measures A according to the units in E, therefore E also measures A according to the units in C. Okay? So, and this is by Euclid Book 7, proposition number 16. Okay? Now, C measures A twice, so E measures A 4 times. Okay? Because there are actually 2 units of 4 in C. For the same reason, E also measures B according to the units in D. This is by Euclid Book 7, proposition number 16. Therefore, E measures A and B, which are prime to one another, which is impossible. Now you say, well, it's impossible if A and B are 16 and 18. Well, what happens if A and B are 8 and 9 instead of 16 and 18? Could 2 measure both 8 and 9? Nope. Not an even number of times. Wouldn't work. Therefore, A and B are the least of those which have the same ratio with them. And that's the proof. I will tell you more in a future video. Stay tuned.